Hey guys, this is Nurluda and I am a verified educator at an academy. Along with that, I am teaching live on an Academy Plus. It's a live platform where educators like me are taking live classes for various competitive exams. I personally teach for CSIR NET, GATE, and TIFR exam. So if you guys are preparing for upcoming CSIR NET, GATE, or TIFR exam, you can subscribe to my classes and you can join my classes on Unacademy Plus. So for that, what you have to do is take Unacademy Plus subscription and there you can attend my classes live over there. Now for that, if you put my referral code, that is n underscore huda, while taking subscription, you will get a discount of 10% on your subscription fee. There are also many offline lessons available on Unacademy. You can enhance your problem solving skills by watching those offline videos as well. So that's all from for this particular part. Now let's continue with our video. Hey guys, hello everyone and welcome to the channel. So this particular video is going to be about an important topic from your chemical kinetics. Now kinetics is itself an important topic from physical chemistry. We have discussed a lot of part of kinetics already, like we have discussed the basic formula of kinetics, like your rate of reaction for zero order first order reaction, like how it is derived, what are the equations, and what are how to solve questions related to that. And I have already done that in a YouTube video earlier. Okay, so I'll give you link of that over here in the I button, so you can like click on that I button and you can watch that video. Also, I've discussed about Maclaurin-Menten equation and like enzyme catalysis and all. So that is also being discussed. So that also link is there in the I button. You can watch it over here. Now this is going to be like one of the part of chemical kinetics where I'll discuss about the parallel reactions, okay, or the side reactions where A is a reactant, it is getting converted into B and C. That means two different products with different rate constants K1 and K2. Now, in this video, in the starting of 10 minutes, I'll try to derive the equation. I'll try to explain that how this equation has been derived. Because whenever you are going for a particular physical chemistry question, especially if you want to understand that very well, you have to do the derivation part of it. So, in order to understand, and if the question is being asked from any formula in between of that derivation, you can do it in the exam. So I'll be taking two questions at the end of this particular video where I'll discuss those questions. One of the question has been taken from my equation in between of this derivation, and a question which was asked in GATE 2019, that was very direct question and that was asked for 2 marks. So you all know what is the importance of physical chemistry nowadays, especially for CSIR net and GATE exams. So that's why this video is dedicated to that. With like this video has been made with that aspect only. So I hope you guys will like this video and yeah, watch it carefully. Now before going into the video part, it's just a humble request from all you guys that if you guys are new to this channel and if you have not subscribed to it yet, do subscribe this channel and like so that you always get notification whenever I upload a new video or I upload anything on the community tab. Okay, so I usually upload videos on a regular basis. From last 2 weeks, I was little busy. I was not well also, so that's why I was not posting videos since long. Many of you have asked me why I'm not posting video. So I was not well and also I was traveling. That's why it was. But yeah, I'll try to be like regular on YouTube. Right? So do subscribe this channel and also watch this video carefully. If you want to ask anything from this particular video, you are welcome to ask in the comment section. So that's all for this part. Let's start the explanation. Alright, so we'll talk about parallel reactions over here. Now I'm back to pen and paper mode like I used to do earlier. Fine, so let's start with it. So this parallel reaction is what? In which you have a reactant, let's say A is your reactant, and it is getting converted into two products, B and C both, with different rate constants. Okay, so the rate of formation of B and rate of formation of C is different for both of them, but the starting material, that means the reactant, is same. So that's why like this kind of reactions are called parallel reaction, in which both of these products are getting formed parallelly. Okay, and which one will be like the rate of formation of whose will be more or whose will be less, that will depend upon the values of K1 and K2. That means the rate will depend upon the rate constants over here. Okay, so A is your reactant, B and C are your product. So remember this thing. So at any time T is equals to 0, that means when you have initial when the reaction has just started, at that place your concentration of A will be A naught. Okay, that will be your like the initial concentration of A, and the concentration of B and concentration of C will be 0. So you have to remember, like, you have to understand this thing. Okay, so it's quite easy, right? It's quite understood that at t is equals to 0, when the time was 0, at that time initial concentration of A is A naught, whereas B and C are 0. Okay, now talking about the rate of decomposition of A. So rate of decomposition of A depends upon the rate of formation of B and C both, and B is getting formed with rate constant K1, C is getting formed with rate constant K2. So if we write down the rate equation with respect to A, that means with respect to the reactant, in that case we will write down that minus dA by dt, that is rate of decomposition of A, is equals to K1A. So it depends upon K1 and the concentration of A plus K2A. Okay, because yeah, so this negative sign is telling you that A is getting decomposed, and these things you know, right? Because the reactant you have. So this is how we write down rate equation. Now if we take A as constant over here, where A is the concentration of reactant at some time t. Okay, now if you take that constant, like if you take that common, so you will get K1 plus K2, and I have represented that K1 plus K2 as K over here. So now your equation will become minus dA by dt is equals to Ka. Okay, what I have done, I have just taken A common here. So how it will be, so you will be having A common, and in the bracket you will be having K1 plus K2. Now in place of K1 and K2 you can write down K, so it will become K into A. So that's what it is written over here. Okay, fine. So now what you can do, you can just yeah, so the next thing is that you can just integrate both side. Okay, and yeah, you can just integrate, and then you will get that this thing. So how you will do that? So once you integrate, so it will become like minus dA by A is equals to K dt, right? And when you integrate both side, so on the left hand side you will get ln A, and on the right hand side you will get kt, right? So what is A now? So A will be equal to e to the power kt, right? This negative sign will be there, so minus kt minus kt. Now well, we'll put the value of k, so that will be minus k1 plus k2, and also integral constant, so c will be your constant of integration, so that will be also there. Now if you put the initial concentrations, the initial values, that means at t is equals to 0, A is equals to A naught, so you will get C is equals to, yeah, so at that time you will get C is equals to ln A naught, and when you put and solve, so you will get this equation. Okay, so this is what you will get when you solve, like when you integrate and put the value of C in this particular equation, and you like ln A is equals to this, so A by A naught will be equal to e to the power minus kt. Fine, I hope this is like you all got this, right? If you have any doubt in this part, you can ask me in the comment section. I'll try to explain it. Okay, although I know that this is quite understandable. Okay, 1 minute, I'll just explain it. Okay, 1 minute, just 1 minute. Okay, so I have just derived it in a detailed way, just to make sure that those who are from non-mathematics background, they also understand this. Okay, so for this is exclusively for those guys who were not able to understand that, right? So okay, so it's like this, that ln A is equals to minus kt plus c. This is what we got after integration. Now at t is equals to 0, your A will be A naught, so put it over here. You will get C, yeah, t will be 0, so you will get ln A naught is equals to C. So that means C is equals to ln A naught. You put it back over here in this equation, and what you will get, ln A is equals to minus kt plus ln A naught. Now take this ln A naught to this side, and you will get ln A minus ln A naught is equals to minus kt. Ln A minus ln B is equals to ln A upon B. So that's what I have used, ln A upon A naught, and that will be equal to minus kt. And if I take this ln, when I remove this ln, it will become e to the power minus kt, and that means A is equals to A naught e to the power minus kt. And when I put the value of k, which was k1 plus k2, so I'll get A is equals to A naught e to the power minus k1 plus k2 into t. So that's how I got equation and the value for concentration of A at any time t. Okay, so this is what we have done over here, and that's what we got in this particular step. Okay, so this is our first required thing. So you can calculate the concentration of reactant at any time t if the initial concentration of A is given to you. Now we will solve some questions also later on, so don't worry about it. Now let's talk about your the concentration of for B. Okay, so if you are given with this
if you have to calculate for B, then how you will get that? So dB by dt is equals to K1 into A, and yeah, so how you will do this? So just integrate this equation again. So when you will integrate this equation, okay, so what I have done, I have just written dB by dt is equals to K1 into A. I have just put this value from this particular equation. Okay, I have just taken the value of it from here, so it will be K1 into A naught e to the power minus K1 plus K2 into T. So that's what I will get. And on integrating this particular equation, what I will get is dB, integration of dB on this side, I'll take dt to the other side, so it will be like integration of K1 A naught e to the power minus K1 plus K2 into T dt. Now over here integration of dB will be B, okay, concentration of B. And over here this is a constant value, so this will come out of the integral. And when you integrate this, so integration of e to the power x, you all know, is e to the power x itself, whereas integration of e to the power ax is e to the power ax by a, right? That means whatever the coefficient of x is, you just take it in the denominator. So whatever the coefficient of t is, you take it to the denominator. So we have minus k1 plus k2, so I have taken that into denominator. Rest of the thing is like that only, plus c. This c is nothing but constant of integral. Okay, this is integral constant. Now again putting the initial conditions, that means when time was 0, at that time the concentration of B was also 0. When we will put this, then what we will get? So yeah, over here this side it will be 0, on this side over here in the power t is there, so we'll put 0 over here, c. So this whole term will become 1, because e to the power 0 is nothing but 1. This whole part, when you take it to the other side, it will become positive in sign, so your c will be nothing but K1 A naught by K1 plus K2. We'll put back to this in this particular equation in order to get the complete equation, the complete like the integral equation of this. So when you will put that, so it will be like B is equals to minus K1 A naught by K1 plus K2 e to the power minus K1 plus K2 into T plus K1 A naught by K1 plus K2. This is from where we got this, from the value of from the value of the constant, okay, the integral constant. So that's from where we got it. Now we'll solve this further. So what I have done in the next step, I have just taken out this particular term constant, K1 A naught by K1 plus K2, and that will give you 1 minus e to the power minus K1 plus K2 into T, and that is what I'll get as the concentration of B. So that's how I can calculate the concentration of B at any given time T, if the initial concentration of the reactant is given. Similarly, we can solve for C also. Why? Because we know that dC by dt is nothing but K2 into A. When you put the value of A again, in the same way we have done for B, right? For B we were having dB by dt is equals to K1 into A, and from that we have derived up to here. So the only difference, the difference is K1, and for C we have K2. So for C we'll get the same equation. The only difference will be that at the place of K1 in the numerator we'll get K2 in the numerator, and this is what we will get the equation for C. So that's how you can calculate concentration of B and C, that means concentration of both the products at any given time t, if the initial concentration of reactant is given to you. Now there is one more relation between concentration of B and C. So the ratio of concentration of B and C depends upon the ratio of rate constants K1 and K2. The more K1 you have, the more concentration of B you will be having. The more K2 you have, the more C you will be having. So it will be like that. Okay. So when you plot the graph, okay, that's more important to understand, that when you plot a graph between concentration and time, so since the reaction was this, that A was getting formed into B and C, right? It was getting formed into B and C with different rate constants K1 and K2. Since A is on the reactant side, so A will always decrease. Okay, so the concentration of A is always decreasing. You can see over here. What about B? So B is on the product side, so B will obviously increase. Okay, the concentration of B is increasing. Also C is also on the product side, so the concentration of C will also increase. Now which one will be on higher side, like whose concentration will be more, either B or C? That depends upon the values of K1 and K2. So this particular graph is representing that K1 is more than K2. That means the concentration or the rate of formation of B is more. That's why the concentration of B is higher than the concentration of C at a particular time. So that's how we derive equation for parallel reaction. In this particular video I'll just like I'll not include the other part of derivations like the consecutive reactions and all. We'll just see some questions which were asked in previous years of GATE exam and previous years of CSI NET exam. We'll try to solve them up, and we'll see that how we'll use this information, whatever we have studied, whatever equation we have done, how we'll use that to solve those questions. Alright, so let's discuss this particular question. It's pretty simple, and I just found it out on in a practice set, and somebody was asking this on Facebook. So I've just taken this question over here in this video. I just thought that this is an easy question. We should start from here. So yeah, it says that A is reactant. It decomposes as, so your reactant decomposes as A is getting converted into B and A is getting converted into C with two different rate constants K1 and K2. So K1 is 2 into 10 to the power minus 3, K2 is 1 into 10 to the power minus 3, right? So they are asking that the rate of appearance of B. What is the rate of appearance of B? They are not asking about the concentration of B, okay? So be very careful with the question, what they are asking and what you have to answer, okay? So don't just go with the flow, and just try to read it out and be very attentive while reading the question, okay? So they are asking the rate of appearance of B taking 2 molar concentration of A at any time t is equals to. So when we will solve this up, so what we will get actually is we have 4 different options. So let's try to do it. So yeah, so rate of appearance of B is nothing but dB by dt. So that's what they are asking, and if you remember, we have done this already. So it's equal to K1 into A, where A is nothing but concentration of your reactant at some time t, okay, and where dB by dt is what? Rate of appearance. So rate of appearance of B is nothing but is equals to K1 into concentration of A at time t. So that's what it is. So we'll just put the values. So we know what the value of K1 is. So we are given with K1, right? It's 2 into 10 to the power minus 3. So we'll write down 2 into 10 to the power minus 3. Then concentration of A at any time t is given to you as 2 molar. So what will be the answer? So 4 into 10 to the power minus 3. From the concentration you will get molar. From the rate constant you will get second inverse. So moles per second inverse. So that is going to be your answer. So option B is your correct option. So that's how you have to solve questions, and this was pretty simple, right? Let's take a little difficult question which was asked in GATE exam. Although see, whatever question will be asked from parallel reaction, it won't be that much difficult, okay? It will be always very easy. So I'll just take a question which was asked in GATE 2019, and we'll see that how to solve that. Alright, so we'll take this particular question which was asked in GATE 2019, and like it was asked for 2 marks. And the question was like that: consider the following two parallel irreversible first order reactions at temperature T. So basically they are asking about parallel reaction, okay, where they have given that a reactant is P. It is getting converted into product Q and R, okay, with two rate constants K1 and K2, where K1 and K2 are rate constant and their values are given to you. That is 5 into 10 to the power minus 10 minus 2 and 15 into 10 to the power minus 2 minute inverse. That means these reactions are of first order at temperature T. Okay, so both the reactions are taking place at same temperature. If the initial concentration of reactant P is 4 moles per liter and the concentration of product R after 10 minutes of reactant is of the reaction is, so they are asking about the concentration of product R. Okay, so that's what they are asking. Now round off, you have to round off the answer up to 2 decimal places. So that's what the GATE GATE people usually do. They ask you to round off the answer up to 2 decimal place and assume that P is present at the beginning of the reaction. Okay, assume only P is present at the beginning of reaction. So don't get confused with this. It's pretty simple, and like it just says that P is present in the beginning of reaction. That means initially your Q and R were not present when the time was 0. So that's what condition is given to you. Okay, so let's try to see that how we will solve this particular question, and just whatever we have studied in this video till now, whatever I have explained you, it will be solved based upon that only. So let's try to solve it up. Right, so according to the question, these conditions are already given to you. That means K1 value is given to you, that is 5 into 10 to the power minus 2 minute inverse. K2 is 15 into 10 to the power minus 2 minute inverse. Initial concentration of P, I have taken it as P naught. Okay, so this is P naught is equals to 4
moles per liter, and they are asking you about at time t is equals to 10 minutes. So you don't have to convert anything, everything is in proper like units, so unit conversion is not required in this particular video. So this is the condition where p is getting converted into q, and it is also getting converted into r with rate constant k1 and k2. Now since we have to find out the concentration of r, we have already done with respect to a, b and c. So over there we have seen that if it was c, like in the numerator we were having k2, if it was b, in the numerator we were having k1. So by that we can remember that if we have to find out the concentration of r at particular time t, then r is equals to what? That will be equal to k2, which is the rate constant of formation of r, into initial concentration of p, the initial concentration of reactant, divided by k1 plus k2, the sum of these two rate constants, 1 minus e to the power minus k1 plus k2 into t. So that's what the equation will be. Okay, now we'll just put the values, since it is a question from GATE exam, so you can just put all the values. So k2 is 15 into 10 to the power minus 2. Okay, so it's 15. Okay, and into p naught is your 4. I'll just put it like that, divided by k1 plus k2. So 5 plus 15 will be, I'm just writing out directly, so 20 into 10 to the power minus 2, and over here you will be having 1 minus e to the power minus 20 into 10 to the power minus 2 into 10. Okay, so this is what you will get, because k1 plus k2 you will get 20 into 10 to the power minus 2, and t is 10. So when you will multiply this, everything will be cancelled out, you will get e to the power minus 2, and you just need calculator to solve all of them. Okay, so it's 15 and it's 20, this will be cancelled out, and this will be 3 times, this will be 4 times, this 4 and this 4 will be cancelled out. So what you will get? You will get just 3 into 1 minus e to the power minus 2. Okay, now you just have to use your calculator, put the values of e to the power minus 2 using scientific calculator. So it will be like 3 into 1 minus 0.135. Solve it up and you will get around 3 into 0.8646. Multiply it and you will get answer around 2.59. So I have just rounded off up to 2 decimal place. So this will be your answer. Okay, so what will be the, so since it is concentration, so the answer will be in moles per liter. So it will be in mole per liter. This is your answer, and in the answer key the answer values from 2.5 to 2.65. So that's what the range is. So since our answer is lying in the range, so this is your correct answer. So this is how you have to do. So simple, you just need to follow the formula, and that's how you can easily solve it. Alright, so that's all for this particular part, guys. I hope you guys like this particular video. Now that's all from my part. Now it's your part. If you guys like this particular video, you can give it a like, share it with your friends, and also if you are new to this particular channel, if you have not subscribed it yet, please do subscribe it. It just gives me motivation to make more videos for you guys, more interesting stuff for you guys, right? So thank you so much for watching, guys. Have a great day. Bye bye.